thank you so much to everyone joining us today for the Community Anchor Program webinar. It's called Johnson County Community Colleges Cloud Connect Experience. My name is Stephanie Stenberg. I'm the director of the Community Anchor Program here. Joining me as co-host is Therese Perlowski, program manager of the Community Anchor Program. And we have 4 amazing speakers we'd like to thank today for joining us to share their time and expertise. They are, in order of speaking, Linda Roos, who is Senior Director of State and Regional Networks at Internet2 Network Services. She's going to tell us a little bit about Internet2's Cloud Connect service. And then we're joined by 2 people from Johnson County Community College, Matt Holmes, who is the Director of Network and Data Center Operations, and Martin Herder, the network architect as well. And they'll tell us about JCCC's experience with implementing Cloud Connect. Lastly, we'll hear from Brad Fleming, who's the Director of Technology of KanREN, the Research and Education Network in Kansas. And he's going to tell us how the R&E network perspective and how he worked with JCCC. And then at the end, we're going to have Q&A. So please use the Q&A box or the chat for your questions, and we will relay them to the speakers. Before we get started, there's an upcoming CAP webinar of interest to many of you. It's called Federal Agency Funding for Community Colleges, and it's going to be Thursday, September 23rd. Trivium Consulting out of Washington, D.C. is going to give us an overview of funding opportunities for community colleges from various organizations. And you can email contactcap@internet2.edu to get that webinar link and invited to the presentation. Therese will put that into the chat right now. When you get the recording of this presentation, you'll also get this relevant links slide. Therese will put into the chat the Internet2 email addresses for more information about Cloud Connect and about CAP as well. So thank you so much. And Linda, please take it away.
Thanks, Stephanie. Just going to share screen here. Okay. So I am Linda Roos. I'm work in Internet2's network services, work primarily with the state and regional networks, but also work on projects like our Networking for Cloud project. And there are 3 different parts to our Networking for Cloud that are available to all of the downstreams from a regional. So that includes Internet2 members as well as entities that are connected via CAP. So, and as a regional, you could offer Cloud Connect, any of these services actually, to all of your downstreams. The 3 services are I2PX, or the Internet2 Peer Exchange, I2CC, or Internet2's Cloud Connect, and I2RPI, or the Internet2 Rapid Private Interconnect. So the peer exchange allows you to leverage the more than 3 terabytes of peering capability that we have to the major cloud providers for access to software as a service type services. That could be Zoom or Office 365. That's when you would use the peer exchange. And it's probably transparent to the downstreams of the regionals. They aren't even aware that they're using Internet2 to get to those types of services. But as a regional, you can provide that service through I2PX. The service that we're going to focus on today is Internet2's Cloud Connect. And this allows the regionals downstreams to use Internet2 as well as the regionals infrastructure to get to the direct connect type services of Microsoft, Amazon, and Google. So you're going to be able to access Microsoft Azure ExpressRoute, Amazon AWS Direct Connect, and then Google Cloud Interconnect, the Partner Interconnect for Google. You can use up to 5 gigs of capacity on I2CC at no additional fee. You use this when you want to extend your data center to the cloud. Perhaps you're moving an application from your local data center to the cloud, and I2CC may be just what you need if you're going to move to one of the big 3. Microsoft Azure ExpressRoute, Google Cloud Partner Interconnect, or Amazon's AWS Direct Connect. And then the third service that we have is I2 RPI. And this provides more than 5 gigs of connectivity to the big 3. So if you need more than 5 gigs of connectivity, you can use RPI and access Azure ExpressRoute, Google Partner Interconnect, and AWS Direct Connect. You can also use RPI to connect to any cloud provider that in the major peering points around the Internet 2 network add a 10 gig connection. So those are the 3 services for Internet 2's networking for cloud. Johnson County Community College used Internet 2's Cloud Connect, and they're going to talk with you about how they did that. So is Martin first or Matt?
Matthew's first.
All right, get the slide pulled up here. All right. Thanks, everybody. Appreciate the introduction, Stephanie and Linda. My name is Matt Holmes. I'm the Director for Network and Data Center Operations here at JCCC. And I've been with the college for about 22 years. And so seeing the college grow and change a lot over the past couple of decades. And kind of a exciting time to talk about where we're at with our Cloud Connect and what we've been doing to utilize these different cloud services. I'm going to start with a little bit of a background and an update on what we've done in the past few years, and then turn it over to Martin for a little bit of a technical deep dive. All right, so to kind of start our story, we first started working with the cloud probably seriously around the 2010 through 2012 timeframe. And one of the things that we were doing at that time was moving things like student email and employee email and things like that out to hosted services. We started seriously looking at developing an actual strategy in 2014. And at that time, we probably had close to 90% of our applications were on premise. We were in the process of moving our ERP out to Banner hosted services, Lucian hosted services. So probably fairly common with a lot of higher ed institutions if you're on the Banner system. We were one of the early adopters of that. So by 2015, we had developed what we kind of called our cloud first strategy, and followed the ECAR and some of the EDUCAUSE guidance when it came to developing that strategy. So at that point, we knew we had to look at our infrastructure pretty seriously if we were going to make a concerted effort towards moving the majority of our applications to the cloud. We knew we would have to beef up our infrastructure. So at that time, probably 80% of our applications were on premise in our data centers, and only about 20% were actually hosted solutions or software as a service. We knew we were going to have to upgrade our border infrastructure, and we were also in the middle of looking at our internal fiber plant and other access layer switching and routing. So once we kind of knew what we had to do, our strategy became operational over the next 5 years. So between 2016 and 2020, we were migrating applications or bringing on new applications and in the cloud pretty regularly. It seemed like every year we were working on 10 to 20 different projects where we were moving things or onboarding new things. So by 2020, our focus had completely shifted as far as our hosting applications on premise. We were probably 80% of our things were in the cloud and 20% were hosted in our data center. Part of that process of that shift was looking at utilizing Amazon Web Services for infrastructure as a service and Microsoft Azure as infrastructure as a service. We also were working on disaster recovery and mission continuity. In 2019, we started an official project at the college to develop business impact analyses for all of our mission critical applications and departments, and continued that development of disaster recovery plans, and worked on identifying different gaps and things that we wanted to maybe change or do differently. A lot of that focus was on applications that were hosted in our own data centers on premise. So we knew we had to look at additional virtualization and replication with the cloud in order to accomplish some of that. So as Linda was describing, we engaged with KanREN and Internet2, and were able to develop both Cloud Connect for Amazon Web Services and Azure in order to extend our data centers out to the cloud and develop some mission continuity and future disaster recovery plans for some of our applications. So with that, I'm going to turn it over to Martin, who is our network architect.
Good afternoon, everyone. Glad that you're here to see what we have to say about our experience with the AWS Direct Connect service. My role here at JCCC is network architect. That's my title, but it's really evolved into technology architect as we converge more and more of our technology into our IP or our campus network infrastructure. This slide here shows a representation of the philosophy of our network design here on campus. We have up top, we have the KanREN Internet to connectivity. We have our border layer with all of our security perimeter, our core layer, which is kind of the intersection of our data network. And then we have essentially two domains on our campus. We have the user domain and we have our data center domain. So anything that needs to leave either one of those two domains and go either northbound or from one domain to the other has to converge through the core network layer. So that's kind of the the overall picture of our data networks. So on to the next diagram. Okay, here we have how we initially connected to our cloud services, AWS, Azure, and Google Cloud Service. As you can see there, JCCC is kind of off on its own little tiny ring that connects to KanREN. Both connections terminate in the same location and at KanREN in downtown Kansas City. And then the traffic traverses another KanREN location in Kansas City. Then we have to go across numerous networks out in the ether to access our off-prem services. So we had a major concern. One was the reliability and the redundancy and the single point of failure. Also, too, we converted our voice system on campus to IP-based voice and incorporated SIP trunk services for off-campus traffic. So when we did that, we encountered a problem with a congestion problem with one of the carriers in the line between our service provider and our location here. So we had to do a lot of hustling and changing around, and thanks to KanREN to get that resolved. So we had a bad experience. So we didn't want to continue that experience with our off-prem services, and so that's when we started. Lo and behold, KanREN came to us, and I2 came to us and said, well, we have this new service here referred to as I2 Direct Connect. So in the next slide, you'll see here, now we're directly peering, the JCCC location is directly peering via BGP with Internet 2. So KanREN is just a transport for us. So we have no blind spots anymore in what networks are traversing to get to our services and where any kind of congestion or latency issues may arise. So now we've addressed the concern of all the layers of networks to go through, but you can see we still have a critical single point of failure in several locations. So working with KanREN and I2, we were able to establish the connectivity, and it's not, it wasn't terribly difficult to do. We were able to establish this connection without too much difficulty. So we were able to bring this up in a couple days, I believe. And as the service matured, we had to go back and make a few changes, but nothing major. So again, with the help of KanREN and I2, we were able to establish this without too much heavy lifting. And in the next slide, you'll see KanREN, our REN network, or our REN or statewide network, was able to establish a redundant or second connection for I2 in Tulsa, Oklahoma. So now we've eliminated the single I2 layer of failure with redundancy both in downtown Kansas City and Tulsa, Oklahoma. And so now we have two paths that we can take if Kansas City has a bad day. All of our traffic will converge automatically to the I2 connection in Tulsa. Our primary is our Kansas City location. And as you can see, the southern regions of the KanREN network will traverse to the Tulsa location. And on the next slide, you'll see how we have everything kind of finalized. We joined the KanREN backbone ring. So now we have full redundancy for our I2 services. We have the connection to Kansas City POP for Internet 2 that directly pairs with I2. The standard configuration is to have a VLAN established from one location in Kansas City and another VLAN associated with the I2 Tulsa link. But since we have two data centers, we have a total of 4. one VLAN pairing with I2 via one data center, and then I2 in Kansas City, and then another the other data center pairing with internet to Kansas City as well. So when you add them all up, we have 4 VLANs. And as I mentioned before, we're BGP pairing directly with I2, and then I2 directly peers with AWS and the cloud service providers in the slide there. So so now we have a full redundant ring or full redundancy in our path for assurance of stable and high availability network connectivity. And then on the final slide.
One thing I might throw in real quick, Martin, on this, just real quick, the having this level of redundancy has been super helpful and super important. Like he was describing earlier, Martin mentioned that we had an issue with a provider once where we were dealing with commercial internet issues. We recently had an issue with our SIP provider where we found that they had a single router in downtown Kansas City that went down and took out our SIP services for a little while. So we know there are those single points of failure out there. And so with this design and utilizing the Cloud Connect service, we're really trying to provide as much redundancy as we can and have it be as seamless as possible and invisible to the user community. And of course, hopefully have everything be self-healing in the event that there is an outage with a piece of equipment somewhere.
Yeah, all of this was designed to dynamically converge without any kind of human intervention. So it's just certain paths are favored. Of course, if that path's not available, then it'll take option 2, 3, and 4 in our case. We also, I believe, we terminate our most of our sessions in Ashburn. Is that correct, Matt? Or is that where most of our cloud services terminate?
Yeah, that's correct. For our ERP system, our Ellucian hosts mainly out of the Ashburn region, and then for JCCC applications that we've spread out across the United States, we've got some in the Ohio region and some in the Ashburn region. We've also got some presence on the West Coast as well. And so you can kind of tell by the dotted lines, JCCC is kind of right in the middle of the map right there. So it's been very helpful for us to be able to show this slide to folks. It helps them visualize where we have the redundancy and how we have the ability to maintain mission continuity for critical applications.
I'm not real certain how up to date this map is, but it may have a newer version out there, but this is the latest one that we've had. I know that I2 has been building out quite a bit of this infrastructure.
So that is the latest map. That's
that
the
is?
exact
Oh,
right
okay.
one. You're all up to date.
Okay, well that's good. That's good. It really, if you can take advantage of this service and you are moving a lot of your applications off premise, you're starting to utilize cloud provider services. This is your best opportunity. We feel very, very fortunate to be in the position that we're in, associated with being a member of KanREN and our association with I2 through KanREN to have access to this service. I can't believe how concerning it can be for other entities or institutions that do not have this available. There's just so many blind spots associated with off-prem or cloud services in the commercial market. So unless you want to pay a lot of money for this type of service that we get from I2. So my hat's off to I2 for providing or foreseeing the needs of institutions like JCCC, and my hats are off to KanREN for all the help that we receive from them for getting this provisioned and successful use. Again, It's not that difficult to do, and it's going to save yourself a lot of headaches in the future. So with that said, that kind of concludes my bit of this presentation. So I am going to turn it over to Brad Fleming, our right-hand man at KanREN. Right-hand person, sorry, at KanREN.
Thanks so much. And just before Brad gets started, if you guys have any questions, please feel free to put them in the Q&A or the chat, and we'll be answering them after Brad does his presentation about how KanREN worked with JCCC. Thanks, Brad.
So I'm Brad Fleming. I'm the Director of Technology for KanREN, and obviously we're the Kansas Research and Education Network for those who haven't heard of us in the past. And Linda already pretty much went through Cloud Connect, but a couple of the specific points that are probably worth making sure everyone knows is Cloud Connect scales at various intervals up to 5 gigabit, at least as it stands today. And that's kind of one of those things that's always being evaluated, and is as bigger physical ports are established, that may also increase. So kind of keep your ear to the ground. But at least today, it kind of caps out at about 5 gig per virtual connection, not per campus, but per virtual connection out to the cloud. And as Linda talked about, there's no cost, there's no additional cost to members of, like in this case, KanREN, GPN, like there's no extra costs that are going to come from the IT side of the fence. And in JCCC's case, there wasn't any cost from GPN or KanREN in this case. And it's obviously, it's really great to extend your data center out to those infrastructure as a service providers, you know, kind of known as the big three, at least today. That's what we have interconnections with. And yeah, the different names for all the different services you got, it's like you know, simple VLAN trunking and VLAN tagging on a physical port can't be called the same thing between 3 different vendors. Just like you can't call private connections to the backside of an infrastructure as a service cloud the same thing, because everyone has to have their own marketing term. So if you've ever heard of those terms before, though, that's the service we're talking about here.
I have to apologize to I2. I just realized that I kept calling it Direct Connect instead of Cloud Connect. So everybody's got their marketing terms. So sorry about that. It is Cloud Connect.
That's just fine, Martin.
Amazon appreciates your efforts to put their name out there. You'll get your 3/4 of a penny check next month. This is the same map that you guys just saw, except I went ahead and threw some physical port capacity numbers on there for the different metros and the different clouds. Down here, this gray box is actually something really important, and that is, if you're looking to lay in new services within a specific metro, let's say it's Ashburn, just as an example, and you're looking through and you don't see quite enough capacity, be sure and ask the IT staff what the status of additional capacity looks like. Make sure that they know that you need that capacity, because they are constantly adding more. They may know that there's something that's going to come online in like a week, and so just give us a week and it'll be available. Or, you know, hey, we really appreciate knowing that you want this additional capacity. We'll add it to the list. That helps us justify the next port with Amazon or Microsoft or Google or fill in the blank, right? So what's really nice to know, though, is in all of these metros, there's significant capacity with all 3 of the clouds, especially as you see, there's tremendous capacity with Azure. So it looks like you can kind of go nuts and get crazy with all your Azure services, at least in Ashburn and Dallas, or I'm sorry, Ashburn and San Jose, go crazy. And I've always said, like, once you lay in all that physical ports, like, it becomes the community's job to burn them up and force more. Like, the best problem to have in the world is we ran out of port capacity and it's time to lay in more, because that's easy to justify with the clouds and everyone else. Okay, we're going to talk a little bit about how this service can be delivered. There's really two primary models. The first one is a pure layer 2 model, and that's a situation where from your campus border, now that could be the border of your campus, like your traditional where the firewall sits, where your border routers sit, or it could be your data centers, or it could be some other part of your network. But we're generically calling that your campus border for this purpose. All the way up to the edge of, we'll use AWS in this example, all the way up to the edge of AWS, it is layer 2 all the way through. So it's layer 2 through, you know, in our case, KanREN, GPN, and Internet 2. The whole thing, we're just passing frames. In KanREN's case, we're going to do it with MPLS services under the hood. In GPN's case, they're just doing switching of the frame from one port to another on the same physical device. And in Internet 2's case, they're going to be doing it with MPLS as well. Your regional could be using EVPN. They could just be doing dual tagging across a provider backbone type setup. It could be all types of fun technologies under the hood. That part doesn't really matter. The part that matters is it's layer 2 from your edge environment to the cloud's edge environment. All of the clouds are going to require you to have a layer 3 hop, though, between your environment and theirs. And that did confuse some folks when we were talking and talking through Cloud Connect as an option, not with Johnson County Community College, but with others within Kansas. Because they thought this was layer 2 all the way in, they'd be able to trunk tons of VLANs back and forth and do VMware style motioning and stuff like that and have the same subnets living everywhere. That's not possible. You need to think about it if you're AWS and you have 1,000 customers that are all coming in off of this service. You certainly can't extend their layer 2 environments into your environment and risk loops and all these various types of problems spilling over into your world, because that's a real bad day if you're AWS. Could impact all kinds of customers, and it's just not worth it. So you're always going to have a layer 3 hop in there, no matter what. So always kind of mentally prepare for that as you're approaching these types of projects. You can find some interesting tunneling technologies that'll like tunnel layer 2 on top of layer 3. Those are at least possible. But the cloud provider is going to force you to have a layer 3 hop. I tell you what, let's go on to the other option as far as design, because I think then we'll cover why you might choose one or the other. Other option is a layer 3 type of design. This is layer 2 from the edge of your campus environment up to Internet 2's first router. Internet 2 then builds a layer 3 VPN. If you're an engineer out there, it's a VRF, right? It's a private route table. And you will BGP peer your campus into the Internet 2 router, and then you will attach endpoints to other Internet 2 routers in those 4 metropolitan areas to the 3 different clouds, however you want to do it. So you'll have your campus will have a BGP session with an I2 router or a couple of them, or in Johnson County's case, you've got 2 data centers and 2 remote I2 locations. So you've got full crisscross setup, you've got 4 of them. And then into your individual clouds, you'll have whatever BGP sessions you need to achieve those cloud interconnections as needed. The really big advantage to this type of arrangement is if you can look at the diagram and just think, well, if the campus goes offline, completely offline, not just one data center, but the campus is completely offline in this type of arrangement, if I have my directory services running on, say, Azure in some sort of Microsoft product, and I have applications living in AWS that need to authenticate users, they don't have to go all the way back to the campus in order to do that process. They can actually just route straight between the 2 different clouds. So the campus can be having a complete power outage or be going through a disaster scenario of some kind, and your applications that are living in AWS can still be online, still doing their authentication just as they always have. which I would consider a pretty big advantage. The other really big advantage that kind of hides is versus a layer 2 environment. If you think about a layer 2 environment, if you're going to have, say, just a simple one-to-one relationship, right? I'm going to have one data center and we're going to talk to one location at AWS. It's pretty simple. But the moment you start scaling this up, it becomes a pretty massive scalability problem. 2 data centers talking to, AWS and to Azure and, something at Google in 2 different metros, and it becomes this huge BGP management problem of just the raw number of BGP sessions and route maps and prefix lists and all this type of junk to try and keep track of. The layer 3 model does help you deal with that scalability issue. Now, that said, there's nothing that prevents you from deploying some services on a layer 3 model. But if you had a situation where, say, for security reasons, you needed to lay up an environment that was layer 2, i.e. all traffic has to come back to campus before it goes to the world or is able to talk to one of these other clouds, you can always lay in a layer 2 environment as well, right? You can always build 2 of these. There's nothing that stops you from doing it. So you can kind of pick and choose or choose both, right? Whatever meets you guys' needs the most. And the tool that you're going to use, I know that this is an eye chart, the screenshots, but you'll be able to download the slides later, and they'll probably still be a bit of an eye chart even. But the tool you'll use to provision all of this is OESS. It allows you to go in, once you have your accounts built, you can go in and provision your campus-facing environments and BGP sessions and put in your MD5 codes and all these things, and then also go through the whole cloud provisioning process. Each cloud is a little bit different, so just kind of be prepared that you're going to need things like your AWS account number, I think is what it's called, and similar types of things. There's a big, long security through obscurity, gigantic hash, I believe out of Azure is how they do it. So just kind of be ready that each process is going to be a little bit different. The first time you lay up a connection with a cloud, I would suggest taking notes of exactly the order of operations and the process and all the stuff you're going to need ahead of time. And I would strongly suggest making sure that you've got somebody from the GRNOC kind of walking you through it on a Zoom session for sure, especially the first time, because you'll learn a million things that you didn't know. And it's always nice, just in case there's some idiosyncrasy to OESS or something like that. It's always great to have those folks on the line.
I could chime in real quick too, Brad. The OESS tool has been really great to have. The first time that we stood this up, we did it all over a Zoom session, and we're watching folks enter in commands on the command line on routers and working with different folks. So if, like on our team, we've got people that are trained up on Amazon Web Services and Azure, and they're used to using those tools to provision networking. This tool works very similarly, and I think would be pretty familiar for most of the engineers that would interact with it. It really does make it a lot easier and uses a lot of the same terminology that they see when they're working with the cloud.
Also, I wanted to add something too. This service, once it's connected and established, it's something that really doesn't need much care and feeding once it's up and running. So it isn't something that we change every day or we need to tweak or tune. The only thing that we've done since we established it is change some VLAN ID numbers and created some additional VLANs. So once it's up and running, it works, and let's leave it at that.
One thing to note though is, as you're working in OESS, the campus-facing connections, they get configured extremely quickly. I think in our experience, they've been like 2 to 5 seconds, the configuration is pushed out and you'll start being able to ping your interfaces and BGP sessions will come alive and all that. And that's, obviously Internet 2 pushing configuration to their own routers, and you already have your routers configured, all that type of scenario. So things come up pretty fast. Things with the cloud can take a little bit of time, as OESS Internet 2 is kind of negotiating with the cloud for certain parameters, like it depends on the cloud which parameters are getting negotiated. So just kind of be prepared for when you go in and make those changes. The cloud sides can take a little bit of time. There can be a little bit of a delay between when you commit things within OESS and when the cloud actually starts showing those in place. So kind of keep it in your back pocket that that's going to take, at times, 20 minutes, 30 minutes even. And I'm sure that there's some cases where it goes even longer than that. But I think that's about the longest we've seen. And then Linda talked about earlier, there is an option, right now Cloud Connect kind of starts to top out about 5 gig per virtual connection. There is a service though, RPI, that allows you to jump all the way up to 10 gig. It's not exactly specifically designed for Cloud Connect. It's designed for other types of services and things that may not be included under Cloud Connect right now. One thing to note though is there is a charge for that service, since you're going to be using a physical resource, and there's going to be cross connects and hard costs to it. So I just wanted to make sure and point that out, that if 5 gig is not enough for you per virtual port with facing the cloud, there are options to go beyond 5 gig. They just take a little bit of time, and there will be a cost to it. And you'll definitely want to talk with the I2 staff to make sure that that it meets your actual needs, and that it's going to be able to integrate with their tool sets and everything else. So if the capacity of RPI meets your needs, I would strongly suggest you talk to the I2 staff and see if they can get it to accommodate you under the Cloud Connect service offering. Some really quick lessons learned. And I don't want to just read this off the slide deck, but the more you treat the data center as just the cloud as a remote data center, the more I think you're going to probably want some sort of performance metrics of reaching that data center beyond just, is the service up? Can I ping that service out in AWS or wherever it's living now? I would, as you're planning your deployments, I would start with just something. It can be super simple, like cacti and smoke ping on something that's out in the cloud on day one, and maybe down the road you upgrade that all the way up to some sort of persona, or maybe you go all the way into some purchased product that someone offers, right? It doesn't really matter how you iterate and improve upon it, but I would always try to start with something, even like I said, even if it's something simple and free. Try to get something stood up just so you have an idea of how things are performing, especially in terms of latency and loss. Those are going to be the two things I would try to keep an eye on pretty close. Throughput's one of those, you can usually tell latency and loss. You probably identify throughput issues pretty quick. And from a regional network or a state network standpoint, campus organizations and users or administrators at the campuses, you just need to make sure that both sides of the fence understand what types of things the regional or state network can help with. And just as an example, like if the campus is having some sort of problem, should they start trouble tickets with I2, or should they start it with the state net or RON, or where should they start if they think it's external trouble with somebody else? And there's a whole myriad of questions that come after that, and things that probably start popping up in everybody's mind. I don't know that you have to get crazy official about everything, but just having a concept that both sides of the fence are like, yeah, start your tickets with us and we'll do our best to troubleshoot up to the points that we can. And then after that, we're going to probably push you off to I2 because they're going to be much more knowledgeable about what's happening on their side. Or yes, start with I2 because they're the ones that run 99% of this environment. So start with them, and if they think it's downstream in between, yeah, then they can engage with us. So kind of think through those things and make sure everyone understands how to proceed with problems, especially. And then the last one I could think of was, if at all possible within your budget and within your time constraints and everything, I would try really hard to do a dry run with setting up cloud connections into whichever cloud you're going to work with. And if that's AWS and Azure, I would suggest really strongly try to budget at least a little bit of money on your project to have those connections stood up for a day extra, right? And that you can stand those up and then tear them out and then later push them back in with full production. That way you can see things like, what does your billing statement look like? How's it going to look like on your billing, so you can show procurement, this is how the bill is going to change. You can make sure that all of your teams understand, like, this is how we're going to do things in OESS. This is the troubleshooting steps that we have, or the tools we have in OESS. This is this troubleshooting we have available to us on the cloud side of the fence. These are all the pieces of information we're going to need. This is how long we should expect. All those things, you actually can do a dry run. I would strongly recommend that, if at all possible, in your budget and your time constraints. And then on my last slide here, just a couple quick, public YouTube demos of the process. I think it's still the accurate process for AWS and Azure, since those seem to be the most popular two clouds. As soon as you get the slides, those will be clickable. So yeah, that's everything I've got.
Thank you so much. So now if anyone has any questions, please feel free to put them in the chat or the Q&A box. One of the questions we had, and I know Brad touched on this a little bit, but just how do outside users connect to the internet to cloud? I didn't know if Matt, you wanted to take that one.
Yeah, I can kind of take a stab at it. It's probably a good question to dig into a little bit. Probably would need a little bit more detail around what they mean by the users. But in our case, being a community college, we don't have dorms, and so the majority of our users are off campus. So it's a good question about, well, how would they utilize these direct connect links? And a lot of this comes down to the architecture of the applications. So if we're developing things like an application that folks are going to be accessing from their business or their home, then the situation is that it's really all about the redundancy. A lot of times they're just going to be connecting directly through their internet service provider to those cloud services through those connections. We do have a few instances on our campus though where it's a resource that the students or the staff or faculty need to access over a VPN connection. So they would actually use a VPN connection back to the main campus and then be routed over the Cloud Connect links to the applications. So a lot of different scenarios, a lot of different ways to do that. But I think the way Brad kind of described it, we're really talking about a pipe, like he said, between two data centers. Only one of your data centers is in the cloud, and being able to route that traffic efficiently over those links. I don't know, Brad, if you want to expand on that any more than what I did.
If we're talking about like users, yeah, it would be the like individual users using an application. To some degree, it would depend upon what IP it lives on, right? And if it's sitting on AWS's IP, obviously they're going to go out there, Comcast, AT&T, whatever crazy home internet connection they've got, and go out to whichever cloud that workload is living in right now. If it's sitting on, and like in this case, a Johnson County Community College IP, it's going to go through the campus and then ride Cloud Connect, and the response will come back to campus and whatnot. There's obviously a way for you to announce in this case, Johnson County Community College could announce a portion of their IP space out of AWS, but that's kind of a whole nother barrel of monkeys and huge, gigantic mess that we won't try to get into too much detail. For the simplicity of the example, I would say it depends upon which, what IP it lives on. And if you're talking, if users are like organizations like campuses and such, then obviously that comes down to access through a RON, through a state net, something like that, into the actual internet to physical fabric and go from there. But once those ports are established, they should be able to do any of these Cloud Connect functions. It's just a question of whether your RON/state net has any special requirements, like if they want to keep some of that traffic physically separate or some of those types of concerns. And that would be a very specific question and answer session.
Part of it too might, part of it is the application as well. For example, our website's hosted in AWS. So if you're at home going to jcc.edu, you're going to go directly to AWS. If you're at home accessing Office 365, you're going to take a different path. But if you're in you're accessing, as Matt mentioned, if you're accessing an academic resource that is that is in one of the cloud services and you need to access it, then you would come in to the college via VPN connection, and then the traffic would then go out those Cloud Connect circuits or services, rather than, as I say, it would look like just accessing resources on the data center that we have hosted somewhere else. So.
Great. And then we had a question. What about authentication? If anyone could speak to that.
Maybe get clarification on which part of authentication between apps, or like authentication to OESS, or what specifically kind of authentication are we looking at? If we're talking about application authentication, that's where it gets interesting and fun, because we can do some really cool things like Brad kind of described. We actually have domain controllers that run in 2 data centers on campus. We have domain controllers in Amazon Web Services, domain controllers in Azure. So our footprint for our Active Directory is really kind of spread out all across the United States, and provides application authentication through CAS or Shibboleth or other single sign-on solutions using Active Directory as the back end. But it can do that through these different Cloud Connect links that Brad described earlier.
That's great. Yeah, that was the question about user access to applications. I was just wondering, Brad, you had some great lessons learned for people. I didn't know if, just kind of as a final thought, any of our panelists had any comments, final comments or tips on, the process, or if someone's considering doing this, do you have any kind of advice to give them?
The one thing I wanted to tag on that Brad was talking about, as far as setting up, it's also, and I think you even had this on the slide, you want to look at your bill, right? So while Internet 2 may not be charging you, or in your state network may not be charging you, cost to data ingress and egress a lot of times, and so does AWS. So you really kind of want to watch how those different cloud providers connections. We've set up some connections where we thought, oh, well, this won't be too bad. It's only, a few cents a minute, but then it piles up pretty quick. So, and depending on the speed of the connection and the amount of bandwidth you want, every provider has different tiers of billing. So it gets a little interesting. And even though they have calculators for it, it's definitely worth the dry run exercise. So
that's great advice. Thank you. Anyone else?
Stephanie, I would just say, if anyone wants to get started, we would be happy to have a call with the regional and the school that wants to get started to kind of talk through high level, actually not even as much detail as we went into here today, but to get you started. And we would be happy to do that. You can send a note to Cloud Connect request, and that email was here in the chat a little bit earlier.
Yep, I just repasted it for everyone. Please do that. Please reach out. It's such a great resource, and you can just do a lot of good with it. So any final comments before we sign off?
One additional lesson learned, and it was not with Johnson County Community College, it was with somebody else, is think a little bit before you think about who needs to be on conference calls and involved and have accounts on day one and such, because especially if you want to move reasonably quick, you've got a lot of schedules to across, in most cases 3 or potentially 4 different organizations. One of the lessons we learned was it can become shockingly hard to schedule those things, and there's a somewhat finite group of people who can actually show you OESS stuff and help you do it and everything. So especially when you're going through like training and such with the GRNOC team, maybe try to keep that number down and just record the session and then go watch the session afterwards would be a lesson learned, if possible, if that makes sense.
That's a great practical tip. Thanks so much. I would just like to thank everyone for joining us today. Thank you to our speakers, Linda, Matt, Martin, and Brad. And if you have any questions, please don't hesitate to email me. If you think of something later, I can pass it along to our panelists. You also have Linda's contact information for maybe getting started with Cloud Connect. And we look forward to seeing you in a couple weeks for the Funding Community Colleges webinar we will be having. So you can email contactcap@internet2.edu if you'd like a registration link for that. Thank you so much for joining us today. Have a great day. Bye.